In this video, we're going to take a look at an acid-base titration. To prepare our acid solution for our titration, we add a known quantity of our unknown acid, in this case 10 milliliters, using what's called a volumetric pipette. A pipette is a very precise measuring tool, and it will give us exactly 10 milliliters. To our 10 milliliters of hydrochloric acid, we're adding 50 milliliters of water to dilute our solution. Into our dropper, we are adding a known concentration, 0.1 moles per liter, of sodium hydroxide. The actual volume we add to our dropper is not as important because we will be keeping track of the volume added by using our drop counter. To set up our apparatus, we have the acid solution in the beaker at the bottom with a stir bar. We have our drop counter and our pH meter, which is submerged in the solution, and our dropper just over the drop counter. The drop counter will count drops of base as it gets added to our acid solution, and the pH meter will take a record of the pH every time a drop is added. Here, our Vernier software will plot the volume of base added against the current pH. We'll see that we started with a very low pH, meaning the solution was very acidic. As we start to add base, the solution slowly creeps up in pH. Over time, the solution will become neutral. We can see that the rate of pH increase is increasing as more base is added, and all of a sudden, the pH is going to very quickly increase. This curve is characteristic of a strong acid, strong base titration, which is exactly what we have. We're using hydrochloric acid and sodium hydroxide, which are strong acids and strong bases respectively. Once we get this S curve, we can pretty much consider our reaction to be over, and we let it go just a little bit longer just to see how the rate of pH decreases near the end. We can determine what's known as the equivalence point by taking a look at the region of the graph where the pH increase is the greatest. For this particular reaction, it will happen around a pH of 7. In summary, using the data provided, determine the volume of sodium hydroxide added at the equivalence point. Determine the moles of sodium hydroxide added, and use that information to determine the moles of hydrochloric acid, as well as the concentration of hydrochloric acid in our original unknown solution.